Hello, this is Hafiz Muhammad Bilal. Today we are discussing access control lists. Topics to cover: overview of ACLs, why do we configure ACLs? In simple words, I will explain when to configure ACLs, understand the scenario, two major types of ACL: standard ACL, extended ACL, advanced ACL, some guidelines, placement of ACL. In the overview, what does access list do? Access list filter network traffic, control routed packets to allow or block at the router interfaces. In other words, your router examines each packet to determine whether to forward or drop the packet on the basis of criteria you specified within the access lists. Why do we configure access lists? There are many reasons to configure access lists. For example, you can use access lists to restrict contents of routing updates or to provide traffic flow control. One of the most important reasons to configure access list is to provide security for your network. You should use access list to provide a basic level of security for accessing your network. If you do not configure access list on your router, all packets passing through router should be allowed onto all parts of your network. In simple words, ACLs are used for traffic classification as well as traffic filtration. For example, you would use a standard ACL for classifying traffic for NAT process, VPNs, or quality of service. Generally, you would use an extended ACL for traffic filtration on the basis of ports. When to configure ACLs, access lists should be used in routers or firewalls, which are often positioned between your internal network and external networks such as internet. You can also use access list on the router positioned between two parts of your networks to control traffic entering or exiting a specific part of your internal network. To provide security benefits of access list, you should at a minimum configure access list on a border routers. Keep in mind that access lists are not enough for security, but at a minimum we should apply access lists. Means apply on the routers situated at the edges of your networks. Understand the scenario. Let's understand we have inside network. Our inside network is having our edge router or border router, as I have discussed before. Apply on the routers situated at the edges of your networks. So we are applying mostly over here on this router. When traffic is coming from inside, for example PC number 2, and going out to the internet, let's consider this is internet or Google server, this interface through which the data or traffic is going into the router, it's called inbound. Inside the router it's being checked and then it's going out of the router, it's called outbound. In other sense, we are saying that when data is coming from inside and getting into the router, that's called ingress port, depends on the direction of the data. And when it's being checked in the router, then it is going out to the internet, this port is called egress port. When it's going to the internet or Google and Google respond back and the data is coming into the router, then at that case the port is called ingress. When it's being checked in the router and going out of the router towards the inside network, then it's called egress. Keep in mind when we are applying ACLs, depending on the direction of the traffic from where it is coming and where it is going. Either it is going outside, either it is coming inside. As we saw in the diagram, ingress traffic flow from the network into the interface and egress flow from the interface to the network. IT, network and security professionals must pay close attention here. ACL starts with a source address first in their configuration and destination second. As you configure an ACL on the ingress of the network interface, it is important to recognize that all local network or hosts should be seen as a source here and the exact opposite for the egress interface. Two major types of ACLs. There are several types of ACLs and most are defined for distinct purpose or protocol. On Cisco routers, there are two major types or main types. One is standard ACL and other one is extended ACL. These two types are most widely used ACLs and the ones I will focus on the implementation of these two in the next lectures. But there are some advanced ACLs as well. Standard ACL, a standard ACL can permit or deny traffic based only on the source address. Standard ACL specify only the source, implying traffic for all destinations. Standard ACL allow you to deny traffic for 192.168.1.20 for example, which completely block the user from any type of traffic. A standard ACL denial means all types of traffic is blocked, data, video or music. In simple points, standard access lists match source only, entire protocol, for example IP. Note, in IP all protocol gets enclosed. For example, port number 80, port number 23, port number 53, any port. ACL numbers recognition, it is starting from 1 till 99 and 1300 till 1999. Where do we place it? Placement of it is apply near to destination, because in standard ACL we do not specify the destination. That's why we are applying it near to the destination. Extended ACLs. An extended ACL can permit or deny traffic based on both the source and the destination addresses, as well as TCP, UDP, ICMP traffic types. Extended ACL selectively deny or permits some or all traffic depending on your performance. On the other hand, an extended ACL can deny only video or music but allow data. This is how the company gets its employees to work. No entertainment at all. Extended ACL, in simple points, it is matching source and destination individual ports. For example, port number 80, port number 443, port number 23, port number 22. ACL numbers to recognize it is starting from 100 and 199 and 2000 to 2699. Where is the placement? The placement of extended ACL apply near to source. Why? Because extended ACL is having source and destination both. It knows its destination. That's why we have to apply near to source. In the previous diagram, if I say this is the source router, so source, and if apply near to destination, this will be the place. If we apply near to source, this will be the place. There are some advanced types as well. Some of the advanced ACL include reflexive ACLs or dynamic ACLs. Going to a definition of reflexive ACLs, also known as IP session ACLs, are triggered from an inbound ACL for traffic initiated from the internal network. The router will identify this new traffic flow and create an entry in the separate ACL for the inbound path. Once the session ends, the entry in the reflexive ACL is removed. Another type is dynamic ACL. Dynamic ACLs are created to allow user access to a specific source or destination host through a user authentication process. Means user should be authenticated over here. Cisco implementations utilize iOS firewall capabilities and do not hinder existing security restrictions. Some guidelines following are some guidelines to configure ACL. Access control list name, depending on the router, it could be numeric or combinations of letters and numbers. Keep in mind that we are having named ACL as well. A sequence number or term name for each entry. A sequence number, for example 10, 20, 30, 40. A statement of permission or denial for that entry. If, for example, we say access list 1 permit specific traffic and the statement deny specific traffic. A network protocol and associated function or ports, for example, include IP, IPX, ICMP traffic, TCP traffic, UDP traffic, NetBIOS, and many others as well. Where to place ACL? Key points to note. Placement and understanding of the traffic flow is important to understand before you configure an ACL on a router interface. Understanding of placement and impact of ACLs are frequent questions in CCNA and CCNP exams, and mistakes in ACL placements are some of the most common ones network administrator make during security implementation. Figure that I have provided earlier a good example of that traffic flow when it comes to ingress and egress on a router network interface. What makes this most confusing is the implementation of ACL on the interface of the router that faces an external network. Look back at the figure. In the example, the ingress side is coming from the inside network, and those addresses are considered to be sources, while external network addresses are destinations. In reply from outside, on the ingress side, your external network addresses are now source addresses and the internal addresses are now destinations. As you add ports in extended ACLs, confusions can mount. The best advice I have before any implementation is to document your flaws and note your source or destination addresses. We will cover more of these implementations later in ACL configuration lectures. In the next video, I will configure standard ACL using the same scenario I have explained in this lecture. Subscribe and keep learning. Thank you.